I'm Josh Berkus. I work for Red Hat in our open source practice office, where I work on a variety of cloud native technologies, primarily Kubernetes, but a variety of other things as well. And one of the teams I work with actually works on something called Podman Desktop, which I'm going to tell you a little bit about. I don't actually work on this, but I use it a lot, and I think you'll see why. Now, what this is going to be about is, this is for people who either already develop containerized applications like on your laptop, or you would like to. I'm not going to cover some things because, for example, one of the questions I often get is, how does this compare with Docker Desktop? And I can't answer that question because I've never actually used Docker Desktop. You'll have to do your own comparison. I'm not going to cover CI/CD. There's ways for that to plug in and everything else. And I'm not going to cover any of the command lines in depth because part of the point of this is to actually show you the UI option, since you can see the command line option lots of other places. Now, one of the things I'm going to mention here, because it is my demo example, is Elekto. Elekto is a online voting open source software package that I and a couple of other people developed for the CNCF, and it's used by several CNCF projects for steering committee elections. And I'm the maintainer for it. So that is one of the containers that I regularly build and test. So now, importantly for our sort of demo example, I just want to explain a little bit about how Elekto is set up so you can see what I'm doing, right? Is that this is our sort of basic architecture of Elekto, which is designed to plug into GitHub to check people's contributor credentials to see if they're eligible to vote. And there's a Python Flask server that runs the actual web app, and there's a database, your choice of database, to store ballots. And the two pieces of it that I need at a minimum for testing are the Flask server and the database, right? One of the things that's on one of my upcoming tasks is to actually create a fake GitHub OAuth server so that we can fully test that portion. Now, you've seen a lot of, there's the command line thing. And actually, I want to talk a little bit about, here's, sort of your basic Docker file, which is what we have set up for building the application. And you can obviously do everything I'm going to show you, you can do via command line tools as well, right? But there are some advantages to GUI tools in terms of making things more visible and actually allowing you to combine several steps into one. So one of the things that's been going on in Elekto lately is we've had a couple of new contributors come in and add a whole bunch of tests that we didn't have previously, which is really nice because I only had about 30% test coverage before. It's now 90-something, which is really good. And we now need to move from unit testing to end-to-end testing. But of course, we have to iterate and launch the application and test that the tests actually pass and that the tests themselves don't crash things, right? So we've got all of that. And this is where Podman Desktop comes in for me, because previously when I first set this up, what I was doing is I was actually running a Kubernetes server on GCP and pushing my new code out to that and actually standing up the application in the cloud. It's nice, but it adds up to a monthly bill. I didn't actually need a cloud server to run it. Particularly not on a modern laptop. So what my coworkers developed is this sort of Swiss Army knife for working with containerized applications. So depending on what else you have installed in your laptop and what your configuration is, you can do just basic container building. And if you've got Podman installed, you can work with local pods and Quadlet. Quadlet's a thing to run pods on Linux machines without having Kubernetes present. You can work with Kubernetes, and you work with several different forms of Kubernetes, which I can show you. There's AI development plugins. There's a plugin for this other project I work with called bootc, which is bootable container images that you can use as an OS image for a machine, and a bunch of other stuff. But the idea is to just, whatever your sort of container development workflow is, to provide a way to plug that into a single UI so that you can sort of work end to end as an individual developer. The other choices, it is called Podman Desktop. So first of all, let me back up. How many people know what Podman is versus Docker? Few people. So yeah. So Docker, everybody in this room has probably heard of Docker, right? And after Docker was created and got popular, a few of the folks at Red Hat had some disagreements about architecture with the Docker project. And so they decided to implement their version of the architecture. They wanted a container engine that was much more embeddable than Docker is, or was at the time. Docker now has Moby, and if Moby had existed at the time, Podman never would have been created. But they created Podman to have that much more embeddable, API-driven version than what Docker was like in 2019, which is when they did it. And I use Podman a lot, but I also have Docker installed for various things. And importantly, I'm going to be demonstrating this on a Linux laptop because that's my workhorse machine running Bluefit. But very specifically, the Podman Desktop team are very interested in the Windows and Mac audience. You can install it on either of those. They're working on a version that's compatible with the new Macintosh containerization. And then there's a whole ton of plugins for various container tools that you might want to use. One thing that you can do with Podman Desktop that I tend to do a lot when I'm testing things, right, is to actually work through the sort of container workflow, right, which is you build an individual container and you see how that works, right? And I was actually doing that just this morning because I was trying to build Elekto with Python 3.14 and it was blowing up. I didn't get past the container stage. And then you have pods, right, which are groups of containers that share a namespace, and then you can have full-blown Kubernetes. And one of the nice things that Podman Desktop makes it easy to do is to actually go through these steps sort of individually so that you can sort of start by testing just one component and then move to building out an entire copy of your app for full testing. So let's do that. And so Podman Desktop, this is my working laptop, so you're going to see a lot of random stuff here has nothing to do with our demo, but that is other things that I'm testing. It's all open source, so it's all fine to be on video. But you start out with your sort of dashboard here, and this is actually already telling me some stuff about what I have, right? Because I have both Podman and Docker installed in this machine. And so for that matter, when I create a container, it gives me a choice of, do I want to run this on Podman or run it on Docker? And I'd have different reasons to do those. So obviously what a lot of container building starts with is it starts with the image. The Podman just gives you a quick shortcut for that because you can just go ahead and build, and then you can say, okay, what am I building here? And here's my source code directory. So I'm just going to take the Elekto Docker file, and that's what I want to build, and then give the image name. And here I said container engine, choose which container engine I'm building with. One of the nice things about it is if your system supports it, one of the things that they offer as an immediate access option here is, a graphical interface for doing cross-compile builds of containers. Not all of these would work necessarily, particularly this application will not work in WebAssembly, but other applications might. And part of this is going to be dependent on what the container engine install on your individual laptop is capable of supporting in terms of cross-compile. I mean, how it'll run on a real-life ARM system is kind of open to question because ARM is one of those specs that's more honored in the breach than in the observance. But yeah, and I mean, cross-compiling always has its limitations, right? But, particularly for I work at Red Hat, which is a subsidiary of IBM, right? I'm not going to wait in the queue for time on an S390 so that I can build there, right? I'll build the container, and if it doesn't work, the S390 people will tell me. And again, this is actually something you can do on the command line, right, with Podman or Docker, but the options can get really hard to remember, and you can spend a lot of time looking it up in the docs, and this is where the GUI is nice, right? Because the GUI abstracts it away from you, and you're going to add custom build arguments and that sort of thing, right? I'm going to start this build, but I'm not going to finish it because there's a lot of dependencies here, and it'll actually take quite a while. But, and as you're building it, it tells you everything that it's doing and that sort of thing. And so if there's an error or whatever, I was kind of thinking of showing you the error with building on 3.14, but it takes about 10 minutes to get to it. So it blows up when it's trying to build pandas, basically. So I'm going to cancel out of that because that would run for a long time. Oh, yeah, for the command line, no. You can always request that as a feature. There are places where we will output portable output. I'll show you when you get to the Kubernetes features, you can ask it to barf up YAML for you. But yeah, no, there hasn't been a feature here to actually have it spit out the command line that it's using. It does give you, this whole log thing, and then you can actually take a look at how it did it. So instead, we're going to do the one that I actually built before this with the latest Python 3.13 instead of 3.14, and we're going to go ahead and start with that. Right? And so one of the first things you're going to do, right, with a build is to run your unit tests, right? So I've got my container image here. I want to go ahead and spin it up as a running container. And then I actually want to get a bunch of things. It's just going to generate a name. I don't care. But here's one of the things I actually want to do here is I want to just run the unit tests. I don't actually want to run the application. So I'm going to replace the entry point for the container. Again, absolutely can do it in the command line, but this way I don't actually have to remember all the switches. I'm not actually defining most of the rest of the stuff because It doesn't matter for running the unit tests, but in a minute you'll see me define it for actually running the application. But I do actually want to define environment variables. So I've got environment variable file here. Right there, it'll take you through a file. You can type them all in individually. There are a whole bunch of other options. I won't say that it actually supports every single command line option that there is, because it doesn't, because there's a lot. I mean, take a look at the doc page for Docker run or Podman run, and you'll see exactly how many command line options there are. But it does actually support a lot of them. Half of them, I think, because of my feature requests. But we'll just run the basic. And so you start up the container here, and it'll go ahead and fire up, and it's going to go through the unit tests. I actually happen to know that, whoops, of course it closes that, but let's go ahead and look at it through the logs. And so you can see there, I know that it's got a problem with the off unit tests, which is what I was testing earlier today. And so this would be like the next sort of debug thing. I actually already know that it's a weird problem with the mocks for the authentication, and we haven't figured out what it is yet. So it's a problem with the actual test rather than with the code it's testing, but it's still failing. So, okay. So I've run my unit tests, right? And so I want to run the actual application, right? So let's go back to the container image, and we're going to go ahead and spawn another instance of it. But actually, before I do that, I'm going to start up something else here, which is, remember I said at a minimum to try out the application, I need two things, right? I need the Flask application, I need a database. So let's go ahead and start up the database. I actually already have a database loaded here. So let's get that running, and now we can actually start up the application. So let's run this again. Okay, and I don't know why this is in there, but okay, and it's just going through the entry point. The Flask app does not need any volumes, as your web application container should not need any volumes. Please let's have separation, and then we're going to attach the environment variables here. And by the way, that's an env file. So we actually wanted to see that. So we've got all of the environment variables that we passed for configuring the application, because all of our users who are using this voting system are running it on Kubernetes, and so it's set up to work that way. Yeah. Yes, it does. Actually, here, you want to see that? Because one of the things you can do is introspect at any time, and that's another way that this, can actually kind of save you time, right? Let's go ahead and take a look at this. So here's our summary, right? We've got this, we've got the actual ID of it, and we've got which engine it's running on, which is Podman in this case, what ports. So it's actually, since this is running on the host system, I have to map ports. So it's mapping to port 1542, right? And it's running, right there as a standalone, and it's running Postgres latest. So that's not really Postgres latest. It's Postgres latest as of about 6 months ago. And you can actually look at a lot. You can pull the whole, so this is the whole JSON that you get out of Podman or Docker for the actual container if you need to look something up that is not in that summary. So let's go back and let's actually run this one, right? So I don't need any volumes. But we need a bunch of environment variables. So right there. And then we actually need to do some port mapping here. So because, wait, 8,000 or 5,000? 5,000, I think. Hold on. Let me look at what I've defined it in 5,000. And we're going to go ahead and start that container. Ooh, whoa, what just happened? Yeah. Ooh, it is not communicating with the Postgres database, which is interesting. Yep. So that's the problem, because the first thing it does when it starts up is it syncs to make sure that the data in the database matches the election data that's supposed to have. And that's where it's failing. Why is it not connecting? Well, first of all, the first thing I want to do is actually want to check, and here's the problem. So let's kill off this. The container is not running anymore because it failed, right? Because it failed. Yeah. Yep. So let's try that again, hey? I have to tell it again because we're going to get this blank form again. So, and port mapping, okay. Let me double check that I saved that. Yes, I did. Okay, so let's try that again, hey? Ooh, it's still blowing up. Shouldn't have to. Well, I will troubleshoot this later. It's annoying not to show you the actual application, but who knows? Maybe it'll actually work when I put it in a pod. Maybe it won't, though. Well, let us try that anyway. We're not looking at containers. That's why we'll get images. So, okay. Now, one little weird thing is when I actually put it in the pod, it is going to be using port 5432. So, yeah. In the interface, yeah. So, and that was actually why I had it saved. Oh, I bet Postgres is not still... Right, anyway, it's going to pick up demo pod this time. So, this is actually going to fail when we first start it up. Oops. But we're going to go ahead and start one based on the pod format, and let's see if it works a little bit better. So one difference between Podman and Docker, as you might guess from the name, is that Podman allows you to run what we call local pods, right? Because for people who use Docker, pods are strictly a Kubernetes concept, where you have a group of containers, they share the same cgroups namespace. As a result, they share network ports, and permissions and a few other things. But if you're using Podman as your container runtime, then it can also run pods in your local machine without having Kubernetes running. And that can be useful for testing things. And also, it gives you an interesting shortcut method if you just want to basically run one pod that might have been designed for Kubernetes, doesn't need Kubernetes, and it's the only thing you're running on a machine, right? Because for me, I'm running my web host with a bunch of old PHP apps, right? That doesn't need an actual Kubernetes server. But having pods is useful because each one of those apps has a PHP thing in a database, right? So, So let's actually start this up, but with a different one and demo pod here. And it's one of the differences you're going to have with the pod demo is that you're connecting locally to other containers in the same pod instead of needing to have their IP address. And I actually think that's what was going wrong with the database. I think it's been long enough since I've started up the database container that it's not assigning it the same internal IP address anymore. Let's see, what else do we need here? Oh, right. Okay. Okay, let's start that container. It won't be able to connect to the database, but that's fine. What happened here? Yeah, but that's fine because we weren't expecting it to connect. So now let's actually go ahead and look at the containers. And so this is one of the fun things that you can actually do is, let's see, is that the one that we want? No, this is the one that we want. So I can take test Elekto pod here, and I can take modest McLean, which is our database, and I can tell it create pod. Oh, right. Hold on. I need to stop the database first, because it is going to create a copy, and we have a port conflict if we don't stop it. Okay. Yep. Yeah. Yep. So, and if you look at this, you can see which containers it's running. There's also this infra container, which makes it work. And those are both running. So let's see if I can actually get the app. Well, that worked nicely. I'm not sure. Okay, hold on. Yeah, because I'm not actually connecting to GitHub to log in. I've got a little goofy workaround, and it just means I need to click login twice. But we've got, a bunch of fake elections that we created and everything else, so you can actually look at the app, right? So that's sort of stage 2 of testing, right? And I can test now a bunch of things as if it was in a pod on a Kubernetes server instead of locally, right? But that's not really full Kubernetes, right? It's a pod with 2 containers. I can't define ingress or have config maps or anything else. So maybe I actually want to test it on Kubernetes. And so that's where we get another big feature of Podman Desktop, which is Podman Desktop will run Kubernetes for you. And hold on. Oops, that was not what I wanted. I want to stop the pod. Let me stop the pod because if I don't stop the pod, we're going to again get potential conflicts. And it'll manage Kubernetes for you. Now, part of it you say, which Kubernetes, right? Because what I'm running right now is I'm running Kind, which is an acronym actually for Kubernetes in Docker, which is a great test environment. It's what we use for testing the Kubernetes code itself, at least for things that are not performance tests or scalability or require ingress access, that sort of thing. And it gives you a lovely opportunity to just run Kubernetes on your laptop for testing purposes. Kind of effectively stubs certain things out. Like you can declare a volume, but it's not actually allocating any storage. So if you have a storage intensive application that you're testing out, you're going to eventually need to move it to some other kind of Kubernetes. And the thing that Podman Desktop is designed to do is to connect to your choice of Kubernetes. Because right here, it tells me what it's connecting to, right? Kind cluster, right? And we actually can't see anything right now because that Kind cluster is not running because Kind runs a Kubernetes cluster inside a container. And in order to have it not interfere with the other tests I was showing you, I stopped it. But here's that container right there. So I need to run that and then I can actually get some stuff, and that'll refresh in a minute. So since it's running on your laptop, your choices running on your laptop are generally going to be Kind or Minikube. People say, what about K3S or whatever? And I say, submit a plugin, right? There's a plugin infrastructure. Nobody's submitted one for that yet, but there's absolutely nothing prohibiting it. But sometimes what you want to do is you actually want to test on a real Kubernetes running somewhere else. And so there's a whole set of plugins for that. I don't have all of them installed, but you can run it on OpenShift, you can run it on external Kubernetes, there was another flavor of Kubernetes that was supported. Lima's supported, and I don't actually even know what Lima is. It's a Mac thing, but it's like a instead of Kubernetes. And other things just lack plugins, right? If your favorite flavor of Kubernetes is, well, GKE, you can pretty much run it with vanilla Kubernetes interface, but some of the others not so. Like if EKS is your favorite flavor, then that's just waiting for somebody to write a plugin, and it might already exist. I haven't checked lately. So now one thing to be careful of is Podman Desktop will only show you one Kubernetes at a time. So if you have multiple Kubernetes defined, right, you have kind for initial testing, and then you're going to have a test OpenShift cluster somewhere else that's like fully fledged for you to run tests on. You've got that defined as well. When you switch between them, you can't see them both side by side. It was an architecture decision to have only one Kubernetes console. And so this is my Kubernetes console. I actually already have a bunch of stuff running on it because I also use this. I work on the etcd project. Someday when we have another speaker cancellation, I'll do a presentation about etcd. And I have a bunch of that stuff from testing etcd 3.6.1 still up here, but that's fine. And so one of the things that we want to do here is we want to go ahead and take this pod that we created and move it to Kubernetes, right? So let's go ahead and do that. It's going to be some options. Replace host ports with services, right? Because if you're running Kubernetes, you want services, not numbered ports. You can get, yes, actually. So when you install Podman Desktop and you start it up, it will modify your kube config to point to whatever Kubernetes Podman Desktop is defined as. So here I'm getting the kind cluster that Podman Desktop is running. So you can drop back down to the kube control command line yourself for anything that for some reason you can't find in Podman Desktop or you're not sure is working correctly. Yeah, so I'm going to go ahead and I think I have an Ingress controller running. Yeah, it's expose 9090 here. Oh, they fixed namespaces. Oh, yay. Okay. Sorry, this was broken in the last release. Okay, we'll go ahead and deploy it. It'll do some work. There are a few of these areas where it's doing significant work where I would like to see some telemetry of what it's doing. And it doesn't have it for this particular interface, but I'll go ahead and do it. No, it is recreating the containers. So like any of the data I had saved in that database is going to disappear. Yeah.
Yeah, you pipeline everything, stuff like that.
Yeah, the idea here, it's just recreating everything from definitions. So I'm not sure that there is a way to actually do migration of the container storage from... Yeah, because if you think about it, what you have to do physically for that is you'd be literally copying the container storage from one system to another. And it's theoretically possible. I mean, they're working on that for Kubernetes nodes, right? For being able to live migrate containers between Kubernetes nodes. For containers where... Okay, why am I not getting a completed status here? Yeah. I haven't tried that, but it would probably work. Okay, why am I still waiting? Is it because I told it to expose an ingress? Yeah. Oh, now remember I told you there's a nice thing is it's actually telling me what it's generating here, right? So this is that. And so it's actually copying the container definition from where I had it in my system and rather than taking the image definition. And where that's useful is if you've sort of ad hoc created the container and made some changes to it, then made some changes to the definition, not to the storage, then it'll actually copy that. Getting all of the... I don't know, it may actually wait forever. So you want to go look at Kubernetes and see if it actually did... Oh, it might have actually done the work already and just not fed back. Let's see. Yeah, I think it actually did the work already. Yeah, because we've already got all of the stuff. So it just did not give me a success message. So I have to look into that and see if I need to file a bug because it created all the stuff, right? So I've got a service called mypod 9090. It's also a service called mypod 5432 for the internal Postgres connection. This other stuff is for Kubernetes, is for etcd testing. We have the pods here, right? Which is, here's my pod here. And that might be the problem. So, pending. Why are we pending? Oh, image pull back off. The classic image pull back off. Okay, so, and here we are. Okay, right. I actually, yeah, it's giving me that. I don't know why, but the thing is it should be copying it from the machine. Okay, I'll still look into that. So we're not going to get an actual running service now because of the image pull back off. Apparently these tried to update too when they're all in image pull back off. Well, that's fun. And config maps and secrets and jobs and that sort of thing. So, yeah. Yeah, and I'm actually wondering if I don't have something set up right on my host for getting the image. So, I actually needed to do a separate step here, which is to push a copy of the image to the client cluster. So because, of course, localhost is not a registry server, so it doesn't respond to registry requests. So let's see if that healed itself. No, it didn't. Yeah. Oh, wait, no, it just did update. Okay. Okay, failed to resolve reference. Okay, we're done pushing. So let's give that a minute and see if it gave up. No, it's repulling it. Yeah. Because environment variables get defined in the copy there. So, and actually, oh, I already closed that interface, but the interface was showing me the YAML that it was doing that included all those environment variables. It gets more complicated if you want some environment variables to then become part of a Kubernetes secret, because you have to take a bunch of extra steps if you want that to happen, because if you're running a host pod under Podman, there's no concept of secrets. But yeah, so I think I should actually have an app now. Yep. There we are. So I have an app, and now it's running on my local Kubernetes cluster instead of running on a local pod. So just an example of a little bit of what you can do with Podman Desktop. Like I said, there's a whole bunch of plugins. There's plugins that show you it all for other things you might be interested in, like one for boot C. There's a whole Podman Desktop AI that's got a bunch of model manipulation stuff for working with AI models. Well, it's a desktop UI, so it's actually running on a desktop container known as a Flatpak, because I'm on Bluefin Linux, which only runs things in various kinds of containers. No, because it's actually talking to dbus the Linux version is talking to dbus for getting the graphical environment, and the Mac version and the Windows version talk to their own graphical environments. This is not a web interface. I think it's Electron, so it's talking to the local desktop, whatever that is. Could you create a web version of this? Yeah, probably. It's just not what we have for Podman Desktop, because it's called Podman Desktop, right? So stuff. I mean, it's just if you work with containers all the time, it's a useful tool to speed up some of the things you do. And also if you have to do a demo for like your coworkers, it makes for a much better demo than the command line. Yeah. So there. Yep. It's free and open source. It is a CNCF project. So yeah. And it is looking for contributors. So if anybody here does in fact program in Element and or work with container runtimes or any of the other stuff, and particularly, they can use people who are willing to work on the graphical front end, because given where I work, we have lots of back end people and not so many front end people. Yep. Yeah. Everything except for the local pods, because Docker doesn't support those. And actually not everything was in Podman, because remember I told you that kind stood for Kubernetes and Docker? There is still a bug preventing Kubernetes in Podman. So in fact, if you actually look at that Kubernetes in a container, that's actually running on Docker. Yeah, so another question in the back? Yes. As a matter of fact, Podman Desktop supports both actual Docker Compose, if you have it installed, and the Podman Compose that supports most of Docker Compose. I'm not a Compose user myself habitually. I'm actually learning it because I have to create some composes for other people, but I don't have that ready to demo because I'm just not that good at Compose. Yeah. But the thing is, the Compose codebase is massive and has a lot of weirdness to it, because it was originally started as sort of a demo hack, and replicating it exactly is challenging. And so if you look at Podman Compose, it'll have a list of things that aren't supported, but it supports the bulk of what people do, right? And if what you have is not supported, then install actual Docker Compose, and Podman Desktop will work with it.
You mentioned that you run Podman, I guess, how that.
Well, that was the middle portion of my demo, showing you this MyPod thing and that sort of thing. Yeah. Well, because basically, if all you care about testing is, hey, is this going to connect to the database, right? Then it can be easier to throw it in a local pod than either work around the alternate address. Because you saw it initially when I tried to stand it up as two separate containers, I had this problem with it not getting the port mapped address of Postgres right. And it's a lot easier if you throw it in a local pod, because then it can just pretend to be on the same server. And that's the reason to use that facility. And the other reason to use that facility is then I don't have to do things, rather than throwing it on the actual kind cluster, is if I'm actually playing with changes to the container image, I don't have to push a copy of the image to the kind cluster, because I can pick it up from my local file system. Yeah. And there's also another reason for you to use local pods, which is that might be your deployment target. Because again, if you're not trying to run a cluster, if you're just going to run a single server or an IoT device that is going to run a few containers, then there's several ways to do that. The way that my coworkers work on is this thing called Quadlet, that is just for running a bunch of Podman containers and or pods on one machine. Quadlet. Yeah. Quadlet. There's a plugin for it. Is it listed here? So you can go through all this. Here's actually all the plugins currently. Yeah, and there actually are some more plugins that aren't listed here because they're in much jankier shape. But if you want to take a chance, you can download their YAML definition and install them. Yeah, and so like, for example, I've got a bunch of old websites written in PHP 4 that I'm still running for various reasons. And I've got those all in containers because they're not really secure. And I'm running those in a single, tiny virtual server on Linode. And I don't want to install a Kubernetes control plane because that would use more resources than all of the PHP websites combined. So instead I run them right. Right now I'm running them under Quadlet's predecessor, which was called Systemd Podman. And at some point when I get around to upgrading them, I'll switch it to Quadlet. Okay. Any other questions? If you've changed the images. It's not a new, I keep that kind server around. I just start and stop it, because when I need the ports it's using, or I just don't want it to be draining my battery. Although it actually uses, if the applications on it are not actively doing anything, it actually uses very little power. I've accidentally left it running while on the airplane and not really noticed. So yeah, but Minikube is running a VM, so there is a kind of constant power drain from the VM overhead unless you suspend it, right? Whereas ultimately containers are just processes, so if they're not doing anything, they consume very little power. Where is that? Kind cluster control plane right here. So I just keep that around. And so if I've already used the image in that kind cluster, I don't have to push it again. But they've talked about various ways to give the kind cluster access to images in your local image store, but it's complicated to actually do. I mean, from my perspective, being able to run a Kubernetes server inside a container is already kind of weird black magic. So, okay. Well, if there aren't any other questions, then thanks, and it's time for games. Thank you.